Hello children, welcome to the My Dream. Today we are talking about the collision and the center of mass. Yes. Today we are talking about the collision. Yes. What do you mean by the collision? The interaction, the colliding, the interaction between the two or more bodies, two or more bodies for a short interval of time. So the interaction between the two or more bodies for a short interval time, that is called collision. And collision are of two types. One of them is the elastic collision. Another one is the inelastic. There are two types of the collision. One of them is the elastic, another one is the inelastic. What are the properties of the elastic collision and what are the properties of the inelastic collision? So now we are talking about the elastic collision. In this type of collision, there is no loss of kinetic energy. The collision is said to be head-on collision. So head-on collision now. If there is the loss of kinetic energy, then the collision is inelastic collision. It means if there is no loss in the magnitude of the kinetic energy, the collision is of head-on. If there is a loss of kinetic energy during the collision, then that is said to be inelastic. Now, elastic collision. Remember one thing, if we are considering the two objects, one of them having the velocity u1, after the collision, their velocity will become v1, v2. Yes. Yes. The line joining, line joining the geometric centers of the colliding objects are same. Before or after the collision, in the line of motion. It means the line joining the geometric centers of the colliding objects, after the collision, the direction is same as that of before. First. Second, in case of elastic collision, momentum remains conserved. There is no loss. In the magnitude of the momentum before or after the collision. Here, momentum remains conserved. Kinetic energy also conserved. Before or after the collision. The mutual forces are conservative in nature. These are the some points in favor of the elastic collision. The momentum is conserved as well as the kinetic energy is conserved. When we are talking about the mutual forces are conservative in nature. Okay? The next is inelastic collision. As I told you before, there is the loss of kinetic energy. In this case, momentum is conserved. When we are talking about the inelastic collision, the momentum is conserved but not the kinetic energy. There is a decrease in kinetic, there is a loss. There is the loss of kinetic energy after the collision. That is half m1 u1 square half m2 u2 square minus half m1 v1 square m2 v2. When we are talking about the forces, here the forces are non-conservative. As I told you before, one of them is the conservative force, another one is the non-conservative. Conservative forces are those which depends upon the initial and the final position, whereas the non-conservative forces are those which depends upon the path followed. So now we are talking about the head-on collision. Head-on collision in one dimension. Let us consider the two objects having the masses m1 and m2. Let us consider the two objects having the masses m1 and m2. They are moving with the velocity u1 and u2. Remember one thing, during the collision, both have the same value. After the collision, they are having the different value. So there is the presence of the two objects. The line joining the geometric centers of the colliding bodies are in the same line. According to the conservation of momentum, momentum before the collision is equal to momentum after the collision. So momentum before the collision is equal to momentum after the collision. Before the collision, that is m1 u1 plus m2 u2. After the collision, that is m1 v1 plus m2 v2. This is by following the conservation of momentum. You can write down m1 u1 plus m2 u2 is equal to m1 v1 m2 v2. According to the conservation of energy, kinetic energy before the collision, is equal to kinetic energy after the collision. And which can be written down half m1 u1 square plus half m2 u2 square, which is equal to half m1 v1 square m2 v2 square. From equation first, you can write down m1 u1 minus v1 m2 v2 minus v2, and from equation second you can write down 1/2 कॉमन ले लीजिए, कैंसिल कर दीजिए, u1 स्क्वायर माइनस v1 स्क्वायर v2 स्क्वायर माइनस u2 स्क्वायर. Divide the equation this by this. इसको डिवाइड कर देते हैं इससे, then you will get u1 plus v1 is equal to v2 plus v2. So it can be written down this one, u1 minus u2, that is v2 minus v2. Then this is the velocity of approach and this is the velocity of separation. Velocity of separation. Now put the value of V2 in equation third or V1 in equation third. So U1 minus U2, that is equal to V2 minus V1. So in place of V2, you can write down U1 minus U2 plus V1. From the equation third, that is U1 minus V1 M2 V2 minus U2. So M1 U1, M1 V1, in place of V2, you can write down U1 minus U2 plus V1 minus U2. So that is M1 U1 minus M1 V1, M2 U1 minus 2 M2 U2. This is of M2 V1. Here M2 V1, M1 V1, M2 V1, you can write down M1 plus M2 V1. इसको इधर ले जाइए बेटा, M1 minus M2 U1 minus 2 M2 U2. So you can write down V1 is equals to M1 minus M2 U1 M1 plus M2 plus 2 M2 U2 divided by M1 plus M2. Similarly, you can obtain the value of V2, that is of M2 minus M1 divided by M1 plus M2 U2 to M2 U1 divided by M1 plus M2. Now, cases. If M1 is equals to M2 let it be m, then it will become 0, m minus m. You cancel, then V1 is equals to U2 and cancel, V2 is equals to U1. V2 is equals to U1. If M1 is equals to M2, let it be M, but U2 is equals to 0. So M1 is equals to M2, so it will become 0. U2 0, तो V1 क्या हो गया? 0 हो गया. U2 is 0, then V2 is equals to U1. This will become 0, M to M until, yes. Next, this is about the elastic collision. Now we are talking about the inelasticity. Inelastic collision. The line joining the geometric centers of the colliding objects in the line of motion. But after the collision, both the objects या more than जो भी हैं stick together. Suppose there is the presence of the two objects having the masses m1, m2, their velocity is this. U1. They will collide, and after the collision, they will move. Then the total mass will become m1 plus m. So, in this case, as I told you before, when we are talking about the inelastic collision, momentum is conserved, but there is the decrease in kinetic. There is a loss. So, according to the conservation of momentum, m1 u1 plus m2 u2 is equals to m1 plus m2 into v. So v is equals to m1 u1 plus m2 u2, m1 plus m2. This is a velocity after the collision. Now, the decrease in kinetic energy, that is half m1 u1 square plus half m2 u2 square minus half m1 plus m2 into v square. As you put the value m1 u1 square m2 u2 square minus m1 plus m2. In place of v, you can add on m1 u1 plus m2 u2 divided by m1 plus. Then you will get m1 plus m2 divided by m1 plus m2 u1 minus u2. Yes. This is the decrease in kinetic energy. Now we are talking about the conservation of momentum. Conservation of momentum. This is a block 1, 2, mutual force of attraction. If no external force, when no external force is applied on an object, then the momentum is constant. So this is 1 and this is 2 for a time interval t. So as you know, P1 is the momentum force on first due to second. This is a momentum force on second due to first. When we are talking about the Newton's second law, so F1(2) is equal to F21 according to Newton's second law. So every action has equal and opposite direction. It can be written down like this also. F21 and this is P1. This is P2. So P1 plus P2 is equals to 0, which is a constant. This is the conservation of moment. आप ऐसे भी लिख सकते हो, the rate of change in momentum which gives the force, and the magnitude of the force is 0 if no external force is applied. When no external force is applied on an object, then the momentum is conserved, which can be written down P1 minus P2, that is equal to P1. The next is oblique collision. When we are talking about the oblique collision, the line joining the geometric centers line joining the geometric centers of the colliding bodies are different. Then this is called oblique collision. The line joining the geometric centers of the colliding bodies are different. Whatever the direction before the collision, उस डायरेक्शन को फॉलो नहीं करता. क्या हो रहा है वो देखते. This one is U1, this is M1, this is U2, M2. टकराने के बाद this resolved into the two components. This one is V cos theta 1, this is V 1 sin theta 1. This is V2 sin theta 2. So, अगर हम बातें करते हैं x एक्सिस की, then we are considering this one. For the horizontal component M1 U1 plus M2 U2 is equal to, let it be M1, this is M2, M1 V1 cos theta 1, M2 V2 cos theta 2. This is on the x-axis. For the vertical component, for the vertical component, ये तो जा रहा ही नहीं बेटा, ये तो है ही नहीं, y axis पे हो ही नहीं रहा. Before the collision, after the collision it will become V1 sin theta 1. This is on the positive y axis, this is on the negative y axis. So you can add on V1 sin theta 1, V2 sin theta 2. So this is about the oblique collision. Now we are talking about the center of mass. The center of mass is the representing point where whole mass of an object is supposed to be concentrated. It is a representing point where the whole mass of the system or the object to be concentrated. That is supposed to be concentrated. Yes. Suppose you are considering a hammer like this, and this is the center of mass. If the applied force is passed through the center of mass, then the motion is said to be translating. तो कैसा मोशन होगा? ट्रांसलेटरी मोशन, लाइक दिस. If this is the center of mass, and you are applying the force like this. Here the applied force is not passed through the center of mass, then motion to be rotatory, in addition with the translatory. Yes. Now we are considering the two particles, and you want to know the center of mass. Center of mass of the two particle system. Center of mass of two particle system. Let us consider the two particles having the masses m1, say m2. There is the presence of the two particles having the masses m1, m2. Their position vectors with respect to the origin are r1 and r2. इस पर कोई एक्सटर्नल फोर्स लग रही है F1, इस पे ले लीजिए आप F2, यहाँ पर म्यूचुअल इंट्रैक्शन फोर्स रहेंगी by following the Newton's third law. So force on second due to first, force on first due to second. Yes. And this is the center of mass of their position vector. Here you see two forces are external and two are internal. This one applies the force on this and this applies on the this. So, as we are talking about the acceleration, that is d square r by dt square, say r1, a2, d square r2 on dt square, now force on first due to second, force on first, force on second, force on external, which is equal to m1a1 plus m2a2. And these will cancel because f12 is equal to minus 2f1. So f external plus f2 external is equal to m1a1 plus m2a2. तो नेट फोर्स जो है that is m into a. So in place of these two, you can write on ma. So ma is equals to m1a1 plus m2a2. So a is equals to m1a1 m2a2 divided by m, and this is the center of mass of the acceleration. This is the center of mass in favor of the acceleration. इसको यहाँ क्यों लिख दिया? Yes. Now, acceleration, that is m1 a1 plus m2 a2 divided by capital M, which can be d square rcm dt square m1 d square r1 upon dt square plus m2 d square r2 upon dt square. So d square rcm dt square d square upon dt square, which is m1 r1 plus m2 r2 divided by this. So this is the center mass of their position vector m1 r1 plus m2 r2 divided by. This is the center of mass of the two particle system. If you are considering the number of particles, then number of particles, center of mass of n particles, then it can be written down m1 r1 M2 R2 up to Mn Rn. M1 plus M2 plus M3 up to Mn, which can be written down summation of this Mi Ri divided by total, or you can write down like this. This is it. If number of particles be n. If you are considering the Cartesian coordinates, then on the x-axis you can write down m1 x1 plus m2 x2 up to mn xn, m1 plus m2 up to mn, or you can write down on the x-axis mi xi. Okay? From I is equal to 1 to I is equal to n. From I is equal to 1 to I is equal to n. I is equal to 1 to I is equal to n. Similarly, you can write down for the center of mass on the y-axis mi yi. I is equal to 1 to I is equal to n, and you can write down for the z-axis this is mi z. Yes. Now we are considering the center of mass of a rigid body. You are considering a rigid body like this. Delta M to the center of mass of this rigid body with respect to the origin can be written delta M into R divided by delta M. ऐसे भी लिख सकते हो आप, वन बाई एन. ठीक है. अब किसके एक्सिस के अबाउट डिस्कस करना है, एक्स वाई जेड, वो आप देख लीजिए. डेल्टा एम the mass of the delta M is the mass of the element, mass of the small element yes. Now now we are talking about the center of mass of a semicircular wire. circular wire. You are having a semicircular wire, and of radius is of capital R. This is y-axis, this is x. And their angular weight be d theta. D theta is the angular weight, and theta is the angle. And this is the semicircular wire, and you are assuming a small element, and you are assuming a small element of mass, this one is x and this is y. So you know about the distribution of mass. Distribution of mass are of different. There is a linear mass distribution, the distribution of mass over the one coordinate out of the three coordinates. Or simply you can say the distribution of mass over a line segment. Another one is the surface mass. This is the linear mass density. Another one is the surface mass density. Suppose you are having a sheet जिस पर आप लिखते हैं, so the distribution of mass over the two coordinate out of the three coordinate. खाली length और width height तो बेटे negligible है ना. When you are talking about the volume mass density, the distribution of mass over the three coordinate out of the three coordinate, or simply you can say the distribution of mass per unit volume. Generally जिसको आप density बोलते हैं. But these all are the distribution. So m mass कितने पर डिस्ट्रीब्यूट है? Distribution of mass on a semicircular m mass दिया है बेटे कितने पर कितने पर. dm कितना दिया है? स्मॉल एलिमेंट. So dm, the mass of the small element, mass of the small element, that is m upon pi d. ठीक है, नोट कर लीजिए. Now, we want to discuss the center of mass, delta m upon m, delta m into r divided by capital M. तो लिमिट कितनी ले रहे हैं आप? लिमिट ले रहे हैं 0 to r. डेल्टा m दैट इज m अपॉन पाई डी थीटा. r क्या है? r आपके पास क्या है? देखिए इस पर क्या है? x एक्सिस पर है r cos थीटा, और y एक्सिस पर क्या है? r sin थीटा. इसको आप ऐसे भी लिख सकते हो. So on the x-axis, x-axis पे ले लें, लिमिट 0 to r, m upon pi है, d theta, r that is r cos theta, this is m upon pi, d theta, limit 0 to r. So it will become r d cos theta and this is d theta r cos का हो गया बेटे साइन, लिमिट दिस की जगह हो गया थीटा, so it is r लिमिट चेंज 0 to pi, this is 0 to pi, this is 0 to pi, this is 0 to pi, limits are 0 to pi, 0 to pi, sin pi minus sin 0, that is pi minus 0, sin 180, 1, 0 हो गया. The center of mass with respect to this x-axis क्या है 0. On the y-axis discuss करें. On the y-axis discuss करेंगे. On the y-axis. So YCM delta m by delta m 0 to pi into r, this is m upon pi d theta, r that is r sin theta, r sin, limit 0 to pi, m by pi d theta, so this is r sin theta d theta divided by d theta 0 to pi, sin it will become minus cos, limit 0 to pi, d theta that is 0 to pi. So minus r cos pi minus cos 0 divided by pi minus 0, cos 180 minus 1, cos 0 1, so it will become twice r upon pi. This is the center of mass on the y-axis. Now you just take a 5 minutes break. Okay.
Hello, students. Welcome to the My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why the My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir.
How
nice it is.
Yay. It's a nice step by the My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to the My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why the My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How
Nice
it is.
Yay. It's a nice step by the My Dream to bring a revolutionary change in recent education scenario. Hello, students.
Yes.
Welcome.
Now we are talking about the center of mass of a semi-circular plate. Semicircular plate. You can consider a plate like this. This is y-axis. This is the radius. You can assume a small element like this. ये हो गया आपका डेल्टा R. This is the radius. This is S naught divided by. This is a small. So first of all, you can consider the mass of this small element. This semicircular plate, the distribution of mass is given by m upon pi r square by 2. This is the area of the semicircular plate. Delta m, this is 2 pi r into dr. So delta m will become twice of m pi r square 2 pi r dr. This is the small. Now, delta m, you want to discuss the center mass about this. Delta m into y. Yes. This is delta m. Limit आप ले लोगे. So you can write down y is equal to 2r upon pi. This is twice of r upon pi. So delta m is 2m upon pi r square 2 pi r dr. This is 2r upon pi, and this is 2m upon pi r square 2 pi r dr. तो कैंसिल हो गए. तो ऊपर क्या बचा? ऊपर बचा बेटे, ये भी कैंसिल हो गया. ऊपर बचा बेटे r स्क्वायर 2r स्क्वायर इंटू dr. नीचे क्या बचा है बेटा? r dr. So it will become r cube by 3. This is r square by 2. The limit is 0 to r. लिमिट कहाँ से लेंगे, यहाँ से यहाँ तक थी तो हमें तो यहाँ तक लेना है बेटा. This is 4 upon 3 r cube. This is r square minus 0. This is 4r by 3. This is the center of mass of a semicircular plate on the y-axis. x-axis पर ये कैंसिल हो जाएंगी ना बेटा, इसलिए नहीं करा. Next. Now we are talking about the center of mass of a hemisphere. This is a hemisphere. This is a small element जो आप ले रहे हो. So r is equals to square of r is equal to square of x plus square of y. So x square is equal to r square minus. And the distribution of mass over the hemisphere, that is 2 by 3 pi r cube. Delta m that is pi r square that is 2 pi r. Pi x square y. So delta m is equals to m pi x square y that is 2 by 3 pi r cube dy. ठीक है, और कुछ देखना है? Now you can go through this. Delta m on the y-axis. This is dy. This is y of the center. Now you can put the values. Now you can put the value that is m upon 3m upon 2 pi x square dy. This is pi r square 2 into y. This is 3m by 2 pi x square r cube dy. कैंसिल हो जाएंगे. कैंसिल कर दीजिए. इसकी जगह लिख दीजिए आप आर स्क्वायर माइनस वाई स्क्वायर डी वाई, कैंसिल हो गया, ये भी कैंसिल हो गए बेटा, डी वाई बचा। ठीक है, इसकी पावर आप क्या करेंगे बेटा, इसकी पावर कर लीजिए, एक वाई भी तो था, वाई आर स्क्वायर वाई माइनस वाई क्यूब डी वाई, लिमिट आप ले लीजिए 0 to r। ना जोड़ दीजिए, यहाँ पे लिख देता हूँ मैं इसको 3/2 m और x स्क्वायर dy y 3/2 m और x स्क्वायर dy by r cube। इन प्लेस ऑफ y, इन प्लेस ऑफ x आप क्या लिखेंगे, बस उसको डिलीट कर देता हूँ, इसको डिलीट कर दो, एक्स एक्सिस पर 0 0 यही है। नाउ in the next section we will discuss the gravitation, gravitation को डिस्कस करेंगे। ठीक है, कर दीजिए।